What's up, scholars? Today we're talking about segment and angle bisectors. So we're talking about segments and angles and their bisectors. Well, what does bi mean? Two sector, kind of like sections, so two sections. We're going to have these segment and angle bisectors. The bisector will split the segment and angle into two equal congruent sections. That's all it is, really. So let's get some formal definitions. A midpoint of a segment is the point that splits a segment into two congruent halves. I rode my bike into school. You can see all that. That's where my clothes are all bunched up, so my skin looks funny. So let's draw a picture of this midpoint. We have this segment AB. The midpoint would be this point M that splits the segment into two congruent halves. Now we mark segments being congruent with these little hash marks. Things that have the same number of hash marks are congruent. So this says that AM is congruent to segment AM is congruent to segment MB. They're exactly the same size. That's what that means. Now a segment bisector is something that goes through that midpoint. Right? So it could be a ray, a segment, a line that goes through that midpoint. A ray, line, or segment that goes through the midpoint. So the midpoint splits it in half, and a segment bisector is something that goes through the midpoint. So again, let's draw a picture. Pictures are always the best. Let's do a segment AB. Let's have M be its midpoint. Okay, so it makes these two halves congruent to each other. And I could have a bisector. Maybe we'll make it a line. It went through M, so it's a segment bisector. Maybe I call this line XY. So XY, line XY is a segment bisector because it went through that midpoint. Bisector. Cool. Now we can find midpoints if they're on a coordinate plane too. So let's say, for example, we've got this point A. It's got coordinates x1, y1. A has coordinates x1, y1. And we've got this other point B that has coordinates x1, or x2, sorry, y2. Those are the coordinates of the points A and B. We can find the midpoint if we add up the x's, divide by 2, add up the y's, divide by 2. x1 plus x2 divide by 2. That'll be our new x coordinate of the midpoint. And y1 plus y2 divided by 2. That's our new y coordinate of the midpoint. Okay, let's try it out. Find the midpoint of segment DE with endpoints D at 3, 5 and E at -4, 0. I'm going to do a quick little sketch. That's how I feel about life. Sketching is best. And I got D at 1, 2, 3, 3, 1, 2, 3, 4, 5. There's D. And E's at -4, 0. So here's my segment. So I know my midpoint should be in there somewhere. So if I get a point that's way over here, I know I did something funny. Try it out again. Okay, so let's label our stuff. D is going to be x1, y1, e is going to be x2, y2, and then we just plug it into the formula, man. So let's call M the midpoint. It's going to have coordinates x1 plus x2 divided by 2, y1 plus y2 divided by 2. Alright, x1 was 3, x2 was -4, so 3 plus -4 divided by 2. And y1 was 5 plus 0 for y2 divided by 2. Okay, keep on trucking. Let's do our calculations. 3 plus -4 is -1. -1 divided by 2. 5 plus 0 divided by 2. 5 plus 0 is 5 over 2. We could leave our answer as a fraction. That would be fine. Or we could put it into a decimal. -0.5. And what's 2 divided by 5? 2.5. Yep. So either this guy is an answer or this guy. Notice we have parentheses around our answer because it's a point. A point has parentheses. We have a comma in between, which indicates it's a point. So let's check our graph. -1/2, 2.5. Like it's right here. Okay, that does look like an appropriate midpoint. It's in the middle there. Great. Okay, find the midpoint of the segment joining. Find the midpoint of the segment joining A and B. So we're doing the exact same thing. We've got our x1, y1, x2, y2. Here we go, here we go. So the midpoint could be adding up our x1 and our x2. -2 plus 3 divided by 2. 6 plus 10 for the y's divided by 2. What's -2 plus 3? Oh, that's 1 over 2. What's 6 plus 10? That's 16 over 2. We simplify, yeah, 1/2, comma 8, or 0.5, comma 8. Those are two possible ways to talk about the midpoint. Question number 3. This one is always tricky because I'm not asking the same question. I'm giving you the midpoint. I'm giving you the midpoint of this x, y. And I'm going to ask you to find the other endpoint. So let's draw a picture here first. The midpoint is at 3, 1, 2, 3, -4, 1, 2, 3, 4. One endpoint is at -3, 1, 2, 3, -1. So y is here, m is here. Where's the other endpoint going to be? Somewhere over here. Okay. There's our y, there's our midpoint. That's in the middle. So its other endpoint's going to be somewhere over there. Okay. So I'm going to show you the easiest, fastest way to do this. Let's stack our points. Y, -3, -1, our midpoint, 3, -4. Our other endpoint is x. Easiest, fastest way to do this. We want to see how the x's moved to get from the one endpoint to the midpoint. And they're going to move the same amount to get to the next endpoint. So what I'm saying is, how do we get from -3 to 3? Well, we add 6. So we're going to add 6 again. What's 3 plus 6? That's 9. How did we get from -1 to -4? We subtracted 3. So we're going to subtract 3 again. So -4 minus 3 is -7. That's our other endpoint. So let's double check. That was 3, 4, 5, 6, 7, 8, 9. Down. 1, 2, 3. Hey, yeah, that looks good to me. There's x. And there's our segment. Cool. All right, I'm going to let you try number 4 on your own, and you'll show me. Great. Okay, an angle bisector, really similar to a segment bisector. It's a ray that cuts an angle into 2 perfectly congruent halves. The way we say angles are congruent is if we give them the same number of arc markings. So these have 1 arc here, 1 arc here. That means this angle CAD is congruent to angle DCB. So our angle bisector is a ray that splits an angle into 2 congruent halves. So here, ray CD bisects angle ACB so that angle ACD is congruent to angle DCB. Split them into 2 perfectly congruent parts. Okay, let's do some examples. Oh, not on that page. On this page. Silly acting. All right, this says ray JK bisects angle HJL. That means these halves are perfectly equal to each other. Given that HJL is 42 degrees, what are the measures of HJK and JKJL? So if the whole angle HJL is 42 degrees, and these 2 parts are equal to each other, what would each of these parts be? Well, I could set this up so that these 2 adjacent angles add up to be the big one. Some of you already know the answer to this question, which is awesome. That's great. I could set this up, since I know by our angle addition postulate that the 2 smaller angles, HJK plus KJL equal the big one. So those 2 measures of the small one equal the big one. I don't know what those ones are yet, though, so I could call them X. X plus X. They're exactly the same, I know that, so they're both the same variable. Equals 42. Combine my like terms. I got 2 x's equals 42. Divide by 2. So x equals 21. So these guys are each 21 degrees. 21 degrees. Very good. All right. 2 more examples. I'm going to set them up, and then you're going to knock them down. In the diagram, ray MO bisects LMN. So these are 2 perfectly congruent halves. I'm going to show you another way to mark these that are congruent. I said they just have to have the same number of arcs. So I could give them both 2 arcs. That still means they're congruent to each other. Isn't that pretty? Yeah. The measures of the 2 congruent angles formed are 3x minus 20 and x plus 10. So let's set it up just like we did up here. The measure of angle LMO plus the measure of angle OMN equals the measure of big angle LMN. That's not as helpful, is it? I know they're congruent. I know they're equal to each other. So let's start there. They're equal to each other. The measure of angle LMO equals the measure of angle OMN. And one of them is 3x minus 20, and one of them is x plus 10. So you're going to solve that for x and show me. And same idea with this last one. Set it up very similar to this guy because it's a very similar question. Solve for x and plug them in. All right, you got it. Nicely done. Go get them. I love you, scholars.